Okay, I'm just going to do a quick follow-up video, which I kind of wish I'd just done this in the previous one, but I paused it or stopped it before I had this idea, which is to just show you what happened if you to the value of delta G if you manipulate the temperature of the reaction. Now, in the caboodle assignment on your marks part 3, which I just did the video for, you're asked to calculate the minimum temperature that the reaction would be feasible at. So that would be when delta G equals 0, then the temperature there would be 822 Kelvin. So you're asked for the minimum temperature that it can be, which means if it's less than that temperature, then the reaction will not be feasible, which means that less than that temperature is going to give you a value where delta G is more than 0. So what I'm going to do is just show you what would happen to the value of delta G if we raise or lower that temperature. So as this is the minimum temperature, I'm going to start by working out what delta G would be if the temperature was lower than that. So I'm going to use 800 K to start with. So delta G equals, where are we? Delta H was 208, and this time we're not going to multiply that by 1,000 because delta G is measured in kilojoules. So I'm going to say that minus 800 multiplied by 253 divided by 1,000 to put our joules into kilojoules, and that will give you a value of plus 5.6, which means that reaction is not feasible because delta G is positive, it's more than 0. If, however, so that's the minimum temperature that the reaction will happen at, if we raise that temperature, it will be more feasible. So delta G equals 208 minus, let's go with 900 Kelvin this time. Again, we need to convert our joules into kilojoules, so divide that by 1,000, and that gives you a value of minus 19.7. So yes, that reaction would be feasible. So that helps you to see, and actually it's quite a common exam question, if you were to raise the temperature or decrease the temperature, would the reaction be more or less feasible? Explain why, and basically that's it. Okay.